This problem has several steps in it. Let's look at what information we're given. We're told that the rate constant for a certain reaction is this, and I'm just going to label it as a rate constant, at this temperature. Alright, and we have another rate constant. I'll label that as rate constant 2 at another temperature. Well, it actually wants to know the rate constant at even another temperature. Well, the first thing that should come to mind is this equation, K2 over K1 is equal to the energy of activation over R times 1 over T1 minus 1 over T2. Alright, well, I have K1 and T1 and K2 and T2, but I can't pick one of those and use with this rate constant because I need the energy of activation. So since I have these two sets of values, I can plug them in, solve for the energy of activation, and then use the same steps and plug in the new temperature to solve for the rate constant at the new temperature. Now, you must remember that your temperature needs to be in Kelvin. So this is 304 Kelvin, and this one is 324 Kelvin. Alright, so let's plug it in. The natural log of 1.38 times 10 to the negative 2 over 2.80 times 10 to the negative 3 is equal to the energy of activation over 8.314 for 1 over 304 minus 1 over 324. And I get the energy of activation is equal to 65,309 joules. So now that I have that, I can choose one of the K's and plug them in. Alright, so it looks like I'm just going to go ahead and use the first set of K's and this next temperature to plug in what we need. Alright, and I'll do that right here. So the natural log of K2 over 2.80 times 10 to the negative 3 is equal to 65,309 over 8.314 times 1 over 304 minus 1 over 338, because this temperature right here is our new temperature, and it's 338 in degrees Kelvin. Alright, so when I solve this equation for K2, I get K2 is equal to 0.03767. Alright, now does this answer make sense? At 31 it's 2.8 times 10 to the negative 3, at 51 it's 1.38 times 10 to the negative 2, and at 65 it would be 3.78 times 10 to the negative 2. So it should be increasing as the temperature increases, and it looks like it's doing that.